Welcome. This is section 11.5 and we will be looking at absolute maximum and minimum values using our first derivatives and second derivatives. Keep in mind the most important part of this calculus is finding the absolute maximum or minimum values. Let's just say you were in the medical field. You want to know what is the maximum amount of the drug dosage or the minimum amount of the drug dosage. What's the maximum time that a patient would recover? What's the maximum profit? Minimum number of goods that or products that you should produce to get the maximum profit. So all these derivatives we are technically looking at finding the absolute maximum or minimum values. So here, if f of c is greater than or equal to f of x for all x in the domain, then f of c is absolute maximum. And f of c is less than f of x is in the domain, then f of c is absolute minimum. Now let's go ahead and take a look at theorems here. A function f that is continuous on a closed interval has both absolute maximum and absolute minimum on that interval. And keep in mind the key here is the closed interval, not the open interval. Now, absolute extrema, if they exist, must always occur, always. I'm going to highlight this one, must always occur at critical values or at endpoints. The second derivative test, we've seen this before. If f prime is 0 and f double prime is greater than 0, then you know it's concave upward. Concave upward means absolute minimum. If f prime is 0, f double prime is less than 0, that means it's concave downward. That is, we'll have absolute maximum on that interval. All right, now let's go ahead and take a look at the problems here. Find the absolute maximum, absolute minimum values of the function over the indicated interval and indicate x values at which they occur. So the first thing is here they gave me the function f of x is 6x minus 5. This is a line, of course. This is a linear equation, a line going up, and I know the value is going to be the minimum value is negative infinity, maximum is positive infinity. But here they told me to find the absolute maximum and minimum in this interval A and this interval B. So the first, they asked me to find the first derivative. Of course, I have 6x, let me do it right here. 6x minus 5. The first derivative is going to be derivative of 5 is 0. Derivative of 6x is 6. And that's what we have. Now they're asking us to find the absolute maximum minimum in this interval and in this interval. So let's start with A, 0 to 3. So what I've done here is I've taken these values, plugged into the calculator, and here I have from 0 to 3. And as you can see, 0 is my absolute minimum and 3 is my absolute maximum. Keep in mind, I'm only looking in this interval. And here is my minimum value, here is my maximum value. And that does match. I have the maximum value is 13. Where do I have 13? At 3. I have the minimum value of negative 5. And where do I have that? At 0. Now part B is, let me erase this one. Part B is from negative 6 to positive 3. And if I look closely here, my maximum value is 13 and my minimum value is negative 41. My maximum occurs at 3 and my minimum occurs at negative 6. Again, how did I get these values? Simply take any function, any value and plug into the function value. So 6 times negative 3 minus 5. 6 times negative 3 is negative 18 minus 5 is negative 23. So the same way I plug negative 6, negative 5, negative 4, and I got these values just so that I can save some time. All right, now let's go ahead and take a look at the next function here, next problem here. They said find absolute maximum or minimum if either exists for, this is again, the easiest way is to go ahead, graph this function and see how the function looks, if you can find the absolute maximum or absolute minimum. This is going to be a quadratic equation, and I know this is something like this, so I know I'm going to have a minimum value, but the maximum value is going to be infinity. You can graph this and check it out. But what if your calculator fails, right? Now let's go ahead and take a look. What did they ask me? They asked me for the first derivative. So looking at the function, the first derivative is x squared is 2x and negative 8x is negative 8. This is my first derivative, f of x, f prime of x. Now, how do I find the maximum or minimum values for this function? What do? Again, I have to find my first thing is to find the critical values. So first step is to find critical values. How do I find critical values? You will take your first derivative, set it equal to 0. So I have 2x minus 8 equal to 0. That is 2x is equal to 8 and x is equal to 4. So x is equal to 4 is my critical value. Now what do? I will go ahead and now find the second derivative. I'm going to use a different color so you can see. So my second derivative is derivative of 2x minus 8 is 2. And as you can see, my second derivative is 2. This is greater than 0. That means I'm going to have a concave upward. That means I will have an absolute minimum value at 4, at this critical value. All I have to do is take this 4 and plug it into the function, which is x squared minus 8x plus 1. So what I'm going to do is I'm going to take this 4 squared minus 8 times 4 plus 1, which would give me negative 15. And I don't have absolute maximum because this is only greater than 0, so I will only have absolute minimum. And again, when you graph this function, it's going to be something like this. I will have an absolute minimum, but the maximum value is going to be infinity. Absolute maximum is going to be infinity. Now, if they gave us a particular interval, and if they gave us a particular interval, then you go ahead and find absolute max or minimum in that particular interval. Okay? All right, now let's go ahead and take a look at the next problem. Again, here they said, find absolute maximum and minimum value. And they said, if this exists. Again, this is, let's say, this is going to be a rational function. And I will have my vertical asymptote at x is equal to 0. So my graphs would be something like this. And I will see that, and I'm looking at this function, just by looking at the graph, I might not have any absolute maximum or minimum, but let's go ahead and take a look. What did they ask me to do? They asked me to, again, how can I say that I don't have a maximum, absolute maximum or minimum? Because keep in mind, they did not specify any interval. If they did specify interval, then I take the values in that interval, like problem 1, and then plug it in, like here, and then find the maximum and minimum. Because problem 1 is again a line, there is no absolute maximum or minimum, but because they gave me that interval, I have to plug the values in there and then find the value and find the absolute maximum or minimum value. Now let's go ahead and see this problem here. What did they ask me to do? They asked me to go ahead and find the second derivative. So I'm going to erase all of this. You know what? Let me keep this graph for your reference. This is again a rational function. This is again a rational function for x is equal to 0. Something like this rational function. Again, I'm not perfectly graphing it. You know what? Let's graph this and see what we get. X plus 4 over x. Yeah, there you go. That's a rational function. Again, there's no absolute maximum minimum here because they did not give me any interval. It's No absolute maximum, no absolute minimum. All right, so here they're asking us to find the second derivative. Let's start with the first derivative. What do I have? I have the function f of x is equal to x plus 4x negative 1. I like to use product rule more than quotient just because I kind of get confused if I'm multiplying the right one or no. So here, it's my function here, my first derivative, f prime of x. Derivative of x is 1, derivative is 4, negative 1 is negative 1 times 4, negative 1 minus 1 is negative 2. So this is 1 minus 4x squared. Did they ask me first or second? Oh, they asked me for the second. Now let's go ahead and find the second derivative. The second derivative of 1 is 0. Oh, this is a minus, sorry. The derivative of 1 is 0, so negative 4 times negative 2 times, my times should be a dot, times x to the power negative 2 minus 1, which is 8x to the power negative 3, or remember, I don't like to have negative. Pearson does not let you put in negative powers, so I'm going to move it all the way to the bottom, and that's what I have. So this is my second derivative. Now you might say, Miss, what if I don't think about graphing? How do I find my absolute maximum or minimums? Very good. That's the good question. Again, what do? I take my first derivative, which is this, and set it equal to 0. So this is, let's move this here, my first derivative. Remember, I'm trying to find the critical values by setting the first derivative equal to 0, which is 1 minus 4x to the negative 2. So 1 is equal to 4 over x squared equal to 4. So x is equal to positive 2 or negative 2. So my critical values are positive 2 and negative 2. Now what do? I take my critical values and plug into the second derivative, which is 8 over x cubed. So I'm going to plug the f of 2, which is going to give me, 8 over 2 cube, which is 1. And I'm going to plug negative 2, which is going to give me negative 1. But keep in mind, okay, so this is greater than 0. So you might think I will have an absolute minimum here, because this is less than 0. You might say, Miss, I'm going to have an absolute maximum here. But keep in mind, this is a rational function. When x goes to infinity, so x plus 4 over x, when x goes to infinity, this whole function goes to infinity, just like in the graph. So it's always good to start with your graph. And again, here, they did not specify any interval. So they said, hey, just give me the absolute maximum or minimum. I cannot have absolute maximum minimum because this goes all the way to positive infinity and all the way to negative infinity. But again, you found your first derivative, you found your second derivative, you found your critical values, you plug them in, and according to them, you might have an absolute maximum, minimum, or absolute maximum. But then you go back and check with your graph because the interval is not specified. And you're going to say, hey, there's no interval. So my maximum is infinity, minimum is negative infinity. That's why you do not have absolute maximum or absolute minimum. All right, so the next one here. Oh, this made my life easy. Look what they said. They said, find the absolute minimum. And here, look, they gave me the interval. I love problems like this where I don't have to think about the graph. Okay, so again, let me write down the function. My function f of x is ex x to the 4. Remember how and what I do? Step 1, I'm going to rewrite this as e power x to the negative 4. Remember, I don't like to work with the quotients. My first step is to find my first derivative, which is, I'm going to use this one, product rule, e power x, derivative of e power x is e power x, x minus 4, plus e power x times derivative of x power negative 4 is negative 4 times x to the power negative 5. When I work this out, I have e power x, x to the negative 4, plus e power, let's say, I'm going to rewrite this one. This is going to be negative 4 e power x, x to the negative 5. Now, when I look closely, I can factor out e power x and x to the negative 5. And now I'm going to take e power x, x to the negative 5 out. And here I have x minus 4. Remember, you always factor out the lowest common factor from negative 4 and negative 5. Negative 5 is common. So that's my first step. Now what do? I set this equal to 0 because I have to find my critical values. And when I set this equal to 0, by default, this cannot be 0. So only this can be 0. That means x minus 4 is 0. So x is equal to 4. So my critical values are at x is equal to 4. Now what do? I don't have to find my second derivative here because I don't have to think if it's absolute maximum or absolute minimum because they already told me to find the absolute minimum. So when they specify find absolute maximum minimum, save yourself some time and don't worry about your second derivative. Now all I have to do is take this 4 and plug it into the function, which is e power x over x power 4. And that is going to be e power 4 over 4 power 4. When you plug that into your calculator, you get 0.21 as your final answer. And again, because they specified this is your absolute minimum, this is your absolute minimum. All right, now let's go ahead and take a look at the next one. Again, here they said find the absolute maximum in this 0 to infinity. So I don't have to think twice and I don't have to find my second derivative. All I have to do is simply find the first derivative. So function f of x is 3 ln 2, make sure I write the right one, negative x. Again, my goal is to find, I don't have to think maximum minimum because they already told me it's the absolute maximum. So I'm going to save myself some time and I'm not going to think about the second derivative because keep in mind second derivative only tells you if it is a maximum or minimum. So I'm not going to do that because they already told me what I'm finding. So I'm going to go ahead, write down my function, and I'm going to find my first derivative, which is 3 over 2 power x e to the negative x times the derivative of 2 power x e to the negative x, which is, I'm going to take the first, this is a product rule, so 2 power x e to the negative x. 2 power x derivative of e to the negative x is e to the negative x times negative 1 plus derivative of 2x is 2 times e to the negative x. Now look what I'm going to do. I'm just going to multiply this whole thing with each and every term. So this is 3 over 2x e power negative x times 2x e power negative x times negative 1 plus 3 over 2x e power negative x times 2 e power negative x. And now all I have to do is cancel, cancel, negative, negative, cancel, 2, 2 cancel, x, x cancel, ex, ex, e to the power negative x cancel. So what am I left with here is 3 negative, which is negative 3, plus, let me see, did I do, plus 3 over x. And remember, I'm trying to find the critical values, so I'm going to set this equal to 0. So I have 3 is equal to 3 over x. In the other words, my x is equal to 1. Again, I'm not trying to find the second derivative because I really don't care if it's maximum or minimum because they already specified it's the maximum. So once I have this, I will take this and plug into my function, which is 3 ln 2 times 1 times e to the power negative 1. And when you plug this into your calculator, you will get negative 0.92. And again, you don't have to think if this is maximum or minimum because they specified this is maximum at 1. So you first find your critical value and then plug that into the function and boom, you're done. Now let's go ahead and look at this problem here. They said describe the graph of f at a given point relative to existence of local maximum or minimum. Assume that f of x is continuous. This is very important. So f of x is continuous. It's a continuous function. I really don't know what the function is. And what did they tell me? They said, hey, you have x and y values. Very good. You have your first derivative, which is 0. That means I have, this is my critical value, right? In here they specified, they told me that f double prime is greater than 0. That means I will have an absolute minimum. If it's greater than 0, that means it's concave upward, then I'm going to have an absolute minimum value there. And I will have a local minimum or an absolute minimum. Hope this helps.